Hello everyone and welcome to another video. So today we are on to week 5 in our flight mechanics class. So why don't we go ahead and do our usual routine of taking a look at where we're headed this week as well as looking at the homework. So week 5, as you can see here by the titles of these videos, we're talking a lot about wind tunnel testing this week. And I think what might help us set the stage for this is let's actually back up and remember where we were last week during week 4. Week 4 was all about sort of setting up our equations of motion for our aircraft, or really for any type of rigid body system that's moving in some inertial frame, right? So if we go back and look at some of those equations of motion from this lecture 4B, this flat earth discussion, you remember where we had this discussion that really at the end of the day what this came down to was you can actually pack these equations of motion quite nicely and quite compactly, right? And these really represent, they're good for an aircraft, helicopter, a brick, anything that's sort of interacting and flying around or moving through space and rotating in space, right? Now, the thing that made these terms interesting and specific to a particular system like an aircraft, where obviously there were things like the mass, the inertia, but really it was this term right here, right? It was the external forces and this term right here, the external moments, right? So let's consider this external forces. Remember, we talked about this in the previous video, right? We talked about how those external forces, you really could think about those as being comprised of, several different subsystems, right? One force that's acting on it is gravity. The other force that might be acting on your object is the engines or the propulsion. And then the last one is the aerodynamics. And this is the most complicated force, right? And we were talking about, well, where would you be able to get the data to populate, or to model this aerodynamic force? Well, that's exactly why we're going to go to the wind tunnel, because with a wind tunnel, it's going to allow us to get static aerodynamic forces, which again are different than unsteady or dynamic aerodynamic forces. That's a discussion for a later day, but the strong function of this FA is mostly steady aerodynamic forces, right? So we're going to go to the wind tunnel to try to characterize this term, as well as if you come down to the moments term, right? We said you could do a similar treatment for the moments, right? The moments are also things like due to gravity, which I guess depending if you do this about the CG, this is probably around 0. But the engines or the propulsion can induce a moment, and also the aerodynamics can introduce a majority of the moments on your vehicle. So again, we are going to go to the wind tunnel to grab this MA term, right? So that's why we want to spend this week here, week 5, talking about the wind tunnel, because it's going to come into play heavily in a lot of engineering applications. Like, that's where you're going to get the information to get the aerodynamic forces and the aerodynamic moments. Okay, so that's this discussion. So I will freely admit that this week is a little bit of a side detour from our usual flight mechanics discussion, but it is a discussion I think that is still valuable and relevant, especially if you're going to go to industry and try to conduct a test yourself to obtain these forces and moments. It'd be good to know what's the theory, how would you go about doing this. So let's start off this quick little half-hour video to start us off is just, what is wind tunnel testing? How do you get data out of a wind tunnel? So some people have never ever seen a wind tunnel before, so I think this will be a nice introduction to, what a wind tunnel is. Then this sort of lengthy discussion is one that I would recommend maybe, skimming through and maybe looking around. You don't have to go through this thing with a fine-tooth comb, but we're going to see that from an engineering perspective, in order to take data that you obtain in a wind tunnel and translate that into something that might be applied to a full-scale free flight condition, you actually have to do a lot of corrections and what's known as data reduction as well. So this discussion, this video here, talks about some of the procedures that are performed at the University of Washington Kirsten Wind Tunnel. Lastly, this video here is going to close out our 3-part sort of wind tunnel discussion to talk about how to interpret the data that you're going to be getting out of the wind tunnel. And if you were designing a wind tunnel experiment, let's say you're a stability and controls engineer or dynamics or an aerodynamics engineer at a company, and the company says, hey, I've got a new aircraft configuration, I need you to go to the wind tunnel and test this. That's a lot to think about, and I'd like to think about some considerations of what you might want to be doing in order to think about how to efficiently design your model, how to efficiently design your run matrix, things like that, and basically how to conduct a wind tunnel test effectively. And then this last little short video here is just talking about, okay, let's say you've got wind tunnel data. We're going to have to start manipulating these aerodynamic coefficient data to apply to our model. So that's our roadmap of where we're headed, is a lot of wind tunnel discussion today. To reinforce some of these ideas, let's talk about homework 5. So, homework 5, the first problem is actually kind of a, I think this is kind of fun. I'd like to get you to go look at the University of Washington Aeronautical Lab, or UWAL. It's also been rebranded as kind of the Kirsten Wind Tunnel, or the KRL. In fact, let me pull up the web page for this. So, the University of Washington Kirsten Wind Tunnel is a place that you might go to actually conduct a wind tunnel test. So you can see there's a lot of these pictures up here, and we're going to talk about this in the video of what some of these models are. But you can go here if you're an engineer and you want to conduct a wind tunnel test. Fun fact, I actually got a chance to work at this wind tunnel for about 3 years when I was an undergraduate at the University of Washington. It's a great place. Students run a lot of the testing. But what I want to do is, instead of thinking about being a student, I want everyone here to think about being an engineer, and you want to go here to this wind tunnel and you want to conduct a wind tunnel test. So one of the first things that you're going to do is obtain what's called a test letter. So a test letter is a lot of, as the description states here, it contains information that the wind tunnel needs to know before you walk in there to conduct your test. So it looks like they want you to call them to get their most recent version of the test letter, but I posted a version of this on the class website. So that's what I mean when it says download the UWAL test letter from the class website. You're going to basically get something that looks like this. And again, I will freely admit that this is probably an older version of the test letter. But all I want people to do here in problem 1 is to just go through this thing and pretend to fill it out like you're going to go in and conduct a real wind tunnel test. So make up a number, make up some test dates. I'm not going to be going through this. The TA's not going to be going through this with a fine-tooth comb. I just want everyone to go through this and maybe make a comment about why do they need some of this information. Obviously, they need your contact information, but if you start looking down here, they're going to need things like your model scale, like how big is your model. They're going to be wanting some things, like if you keep scrolling down here, like what is this? What is a ground plane? Well, we're going to talk about that in the video, right? Why do they want these numbers? What are they talking about? Dynamic pressures. They want you to fill in some numbers here. They want things like blockage corrections. You need to pick all this. So again, you can't just walk into a wind tunnel and say, hey, I want to test this thing. You've got to do a lot of work ahead of time so you can try to fill out this test letter and understand what are some of the considerations that you might need to do before you start conducting your test. So again, just fill in this information with some made up but quasi-reasonable numbers. Like, don't tell me that the reference of your model, the reference wingspan of your model is 30 feet when the test section is only, I think it's, 12 feet wide, right? So I'll let you think about this, but basically I would recommend watching these 2 videos first. In fact, probably I would recommend watching all 3 of the videos first, and then all of the stuff in that test letter is going to make sense. In fact, I provide some numbers here for a full-scale aircraft. In fact, this is going to be some parameters for our research civil aircraft model, or RCAM video, or model, excuse me, that we're actually going to be building next week. So I'd like to think about this week in week 5. Let's say you want to drop into the wind tunnel with this aircraft and test it. How would you go ahead and do that? So problem 1 is just fill out that test letter and then make educated guesses as to why the wind tunnel needs all that information. Okay, so that's problem number 1. Problem number 2 is, again, just briefly describe what are some of these values that are needed or discussed or used at these different steps in the data correction and data reductions process. So again, if you watch this video, you're going to pretty much see that I go through each one of these corrections and talk about what they are, what all of these parameters are, what these numbers are. Are they positive, negative? Are they matrices? You know, what are these things? I just want to make sure that people have a reasonable understanding about what all these corrections are and what are some of the parameters that you might need to compute or provide at each of these steps. So problem 2 is, yeah, don't think about this thing too hard. It's just describe these variables and sort of their structures. Okay? Problem 3, I'll let everyone read about this. There's a ton of words here, but again, I have a lot of words just to make sure we're very precise about some of these distances. These are all about doing what's known as moment transfers, and again, we talk about moment transfers in this video here on tunnel corrections and data reduction. So I'll let everyone read about this, and I think it should make pretty good sense once you read through the description. Problem 4 is about a weight tear. And again, I think it would probably be easier if we watch the videos first, and you'll see that this is actually not that complicated an idea. All you're trying to do is correct for the fact that the CG of the model in your wind tunnel is not going to be, it's going to induce some rolling and pitching moment on the balance that you're going to measure. We need to tear that out. So this is a procedure that is sometimes done in order to obtain that correction. And you can see it's really just solving a bunch of equations algebraically. Of course, these equations might not be fun, so I wouldn't recommend doing this by hand. I would recommend using something like Mathematica to actually perform these manipulations. Okay, and then lastly, problem 5 is let's go through one data point. Let's say you collect this one data point of roll, pitch, yaw, lift, drag, side force from the wind tunnel, right? The balance reads this. How are we going to take this one data point, run it through all of these corrections we talked about, and produce a coefficient, an equivalent data point which is in reduced coefficient form for a full-scale free air model? So I provided some skeleton MATLAB code on the class website that outlines some of these processes and procedures that we talked about in this video. So all you need to do is just download that code and then just start filling it in. And again, all we're trying to do is just perform data reduction for one single data point here for our wind tunnel model. So yeah, that's the game plan. So, I think that's pretty much it for week 5, so I don't want to hold anyone up. I want to keep this kind of as short and sweet as possible. Week 5, again, all about talking about wind tunnel testing. We went over the homework, and again, just to set the stage, the reason we're doing all this is because next week we are going to use this information and the processes and procedures to actually apply our flat Earth equations of motion from week 4. We're going to apply actual aerodynamic forces and moments like what you would get in the wind tunnel and use that to build a flight simulator model. So a 6 degree of freedom nonlinear aircraft model is coming next week. We just need some of this discussion on wind tunnels to get the aerodynamic forces and the aerodynamic moments on that model. So, with that being said, send me an email if anyone has any questions. Otherwise, yeah, that's the game plan. I think I'll sign off. Talk to everyone next week. Bye.